No Zoom burnout here, folks. Today we're headed to Canada for another great podcast conversation. Hello, and welcome to this edition of The Better Satellite World, the podcast of Space and Satellite Professionals International. I'm Lou Zaccarella. We've been taking a look at the importance of high-performance ground segment as the key to unlocking opportunities for small, but for many LEO satellites and fleets as large as those operated by SES and other large operators. The action could very well be on the ground. But with much acclaim, Telesat developed a highly innovative global network of 298 state-of-the-art low Earth orbit satellites, seamlessly integrated with its data networks on the ground. With its long technical heritage and priority Ka-band spectrum rights, the Telesat product is in contrast to SpaceX and Amazon constellations because it seems to be focused on the enterprise and B2B markets. So what unique challenges does this present, and how does Telesat close the link between their new LEO fleet and the all-important ground segment? Well, we'll ask someone from Telesat about this and much more. But first, this series is underwritten with the generous support of Isotropic Systems, designers of the world's first multi-service high-throughput terminals. You can learn more about them at isotropicsystems.com. Additional support for the Better Satellite World comes from Eutelsat, EchoStar Hughes, Peraton, and Access Intelligence, content with context. And from the 3,000 members of Space and Satellite Professionals International and its international chapters, including our UK chapter, host of the Better Satellite World Awards virtual dinner on December 7th. Thank you, SSPI. Well, Manik Vinnakota is the Director for Commercial and Product Development at Telesat, and we've invited him here today to talk about the new fleet, the changes in the ground segment infrastructure, and a lot of other things that are relevant to Telesat and our industry. Whenever I moderate a panel on LEO fleets, it is always agreed that Telesat LEO, your new constellation, is going to emerge as one of the winners of the LEO space race. Manik, welcome, and why is that?
Hey, Louis. Firstly, thank you for having Telesat and giving us the opportunity to talk about Telesat LEO, which all of us at Telesat are very excited about. I'm very glad that on all your panel discussions, Telesat LEO comes up with high credibility. But as you mentioned in your opening remarks about the focus of the customers we are focused on, it starts with that. We've been on the Telesat LEO journey for a bit more than 6 years now, and being the only satellite operator we've been in business for more than 50 years now, we had the luxury and the benefit of working very closely with our customers as to what do they want in the future. How can we put them in a best position for the future of satellite networks? So we started from that, and we worked backwards from customer requirements. And that's how we came up with the Telesat LEO network that we have today, that we've designed for it. We are technologists at heart, but from how to find the best technology to solve a customer's use case and requirements.
Yeah.
So from day one, we were very focused on serving enterprise customers, as you mentioned in your introduction, and we looked at every possible technology that's out there from building, which will help in build a LEO constellation. And we think we've got we've got the optimal mix of everything to make sure that an enterprise customer, whether it is a telecom operator like Verizon or someone who's serving the aircraft or the maritime market, we've tried to make sure that we've got just the right enough technology there, so it serves their technical requirements, but also from an economics perspective, because great technology should also come with great economics. So
absolutely,
I think we're at that point now, and happy to elaborate more on the technology angle.
Well, there are some, thank you for that. There are some unique technical features to this fleet, as I understand it, such as hybrid orbits and many more. And as you say, you try to match the technology to the need of the customer, which is very smart as opposed to just throwing technology at them. Can you describe some of the technical dynamics of the fleet that you think are appealing, and the ones that allow people to come up to me at these conferences and say, Telesat Leo, yeah, I think they're a winner.
Mhm. Yeah, there'll be, I'll focus on four of them. If we had our engineering team, we could go on all day, but I'll just focus on the four key technologies and how they help in serving the enterprise arc focus markets better. So we start with the orbits. That is, Leo is but an altitude of how high your satellites are. But how do we design, and where are these satellites going to be above Earth? So that's what the orbits are. Um, and we've come up with a unique architecture of combining polar and inclined orbits. The polar orbits being satellites that go over the poles, and the inclined orbit don't go over the poles. They are slightly inclined. And the reason we came up with this was because demand is not uniformly distributed around Earth. You need to put satellites or capacity or supply where there's a lot of demand. But on the same side, there are customers or planes that fly over the poles, or northern communities in Canada and elsewhere that do not get served today at all, or well enough by traditional geo satellites. So hence we came up with this unique mix of orbits, which makes us cover the entire globe, but also concentrates capacity where there's demand. So we start with that. So that was the number one difference of having this mix of orbits. But also important is after the orbit, is what do you put in these orbits? What is the satellite that you're designing and launching and putting into space? And there's a whole range of satellites you can put in Leo. But the satellites we've decided to put were highly flexible, state-of-the-art satellites. And by flexible, I mean the beams that these satellites will have are highly flexible. They can be uh, changed, they can be steered. Basically, they will adapt to the demand that they're seeing on the ground, so that you can have a very large beam if needed, you can have a very concentrated beam, and you can even aggregate beams from multiple satellites over a region if needed. For example, take a big airport like Miami or the Atlanta. During peak rush hours, there are a number of aircrafts over them. And to serve those areas, a lot of our satellites will concentrate many beams so that you have a lot of supply there where there's demand. But when they are flying over the ocean, or less spread out demand, they'll move those beams and spread them out to serve the demand. So the flexibility of the constellation is also very important, because demand again is not uniform. All these satellites, this is the third point, we've interconnected all these satellites with what we call inter-satellite links. So these are laser links or optical links that will make sure that you're not just being served by a satellite at a time, but you've got an entire network in space, a mesh that is all these satellites interconnected that is serving you. Some of the customer benefits, the network becomes highly resilient, because now if you cannot see a ground node, if the satellite cannot see a ground node, it can talk to its friend through the ISL and route traffic to another ground node, because it's an interconnected mesh. Think oceans, where you really cannot build gateways on the oceans, but you still continue having coverage, because the satellites will talk to each other and take traffic back to the nearest gateway. So for multiple reasons, the mesh made more sense to us than not having inter-satellite links.
Is there onboard data processing with
yes,
the link satellites?
Yes, definitely. Thanks for reminding me. All these satellites also have onboard processing. They are not bent pipes as geo satellites are traditionally. And again, the reason for doing that was it helps improve the overall efficiency of the constellation, because you can have very big efficient links on the feeder link side, because the whole signal is processed on board on the satellite.
Mm-hmm.
And finally, all of these, LEO is LEO constellation. We have 300 satellites in our constellation, which will be talking to multiple thousands of terminals and number of gateways. We have we will be building what we call a constellation network operating system that is going to put all of this together so that the user doesn't have to worry about which terminal or which satellite or which beam he's connected to. All he needs is the service that he wants to be delivered, and the constellation network operating system will orchestrate all these different nodes in the network and deliver the service that we had promised to the customer.
Yeah.
So that's how everything comes together as well.
It's extraordinary. It's an extraordinary leap for satellite industry to have that level of complexity, but also that level of network capability. And I'm struck by the Constellation Network Operating System. Of course, we were speaking in the last episode with Jeremy Turpin of Isotropic, who was talking about that sort of orchestration component, and it is obviously going to be it is one of the game-changing features. I want to bring us back to the ground, if we can, Manik, and talk about the ground support. Isotropic's phased array antenna is prominent for LEO constellations. Why is phased array a solution, and a solution that's important to the B2B or enterprise sector, which again Telesat is targeting? Is there some advantage that technology is giving you that you heretofore hadn't been able to achieve?
Mm-hmm. Sure. So I'll state the obvious here that when we talk of LEO constellations, the user terminal where phased array antennas will be used need to be connecting to different satellites as the service goes on. So depending on how the LEO is built, you could be talking to a satellite on average maybe every 5 or 10 or 15 minutes, depending on where you are and how high or low the satellites are. So you need a very efficient, effective user terminal that will keep doing this seamlessly. It will keep, while it is connected to one satellite, it can stand up another beam to scan for the next satellite so that the link is already set up on the next beam while this beam is kind of ends on the satellite which is setting in the horizon.
Mm-hmm.
So that's one requirement. I mean you need that to be able to operate with LEO. Over and above that, again going back to our customers' view, customers want antennas and terminals that are multi-orbit capable. What I mean by that is they want terminals that can talk to LEO constellations, but also constellations in MEO and GEO satellites, because that gives them resiliency, or they have for different use cases. Perhaps they're using a C-band satellite in GEO for something else, and they want a higher throughput satellite on a LEO. So for various reasons and economics or network design, they want antennas that work across orbits. So for both these reasons, to efficiently work with moving satellites, as well as being able to operate on multiple orbits, phased array antennas are great to help solve this problem for customers. Talking of specific market verticals, think the aviation market. If you want to be connected, today the market is mostly dominated by mechanical antennas, but as you would know, an aircraft operator would want anything that reduces weight and add weight to the aircraft. And phased array antennas have a much more flatter profile, which makes sure that they're not adding weight to the aircraft and they're reducing weight. So that's a big plus. When we think of more luxury markets, think the super yachts, for example. Their aesthetics are also important, and a flat panel antennas or phased array antennas can add to the aesthetic angle as well, in addition to solving the
Yeah.
connectivity dimension.
Yeah.
So for multiple reasons, phased array antennas are important to the enterprise market, to the B2B market. Um, but I would definitely also add that there is the alternative of dual parabolic antennas, which is two parabolic antennas to connect to a LEO constellation. So we at Telesat believe it's going to be, the market is going to ask for both of them, depending on the use case, as always, going back to the customer. But phased array antennas, once they're solved for from an economics and an efficiency perspective, they're going to be very helpful to the satellite market.
Yeah. Um, we didn't have this on our list of questions for you, but have you encountered use cases on the commercial side that you didn't expect, where you said, gosh, we didn't know this kind of customer existed, or we didn't know this use case would pop up, but gosh, there's an unintended consequence of a good technology.
That's the fun part. We are always discovering new use cases. Again, going back to Telesat's heritage, we are building a very new constellation, but we've been studying this market, like I told you, to make sure we are addressing 100% foolproof use cases. So there's the traditional market that we definitely see, but every month or so, new use cases keep coming up. I'll just give you two examples. One is I'll talk of business jets. We thought the smaller business jets, again, business jets is a whole large category, from very large intercontinental business jets to the small 6-passenger. At the lower end, the smaller business jets, we had imagined that the terminal wouldn't be small enough to fit on them, to look good on them, and perhaps it's not an addressable market because there are other ground-based technologies doing it. But we are being proven wrong. Going back to phased array antennas, there are very efficient, very small phased array antennas that are being developed that will help address the smaller end of the business aviation market as well. Think of land mobility, trains. There are a number of European institutions looking to connect trains that run across the country, and all kinds of trains, commercial, passenger, again, to keep passengers connected, but also to track the train. And again, you need good antennas to deliver very high throughputs, especially if you're talking about a few hundred passengers. So I'll stop there, but there are a number of interesting use cases that are coming up that need very high throughput at good economics.
Yeah, that's interesting. You know, the final question we always ask, because obviously the name of the show is The Better Satellite World. We know that our satellite community makes the world a better place. What would you say from that broader perspective is going to be the ultimate determiner of success for the LEO fleets? Is there one criteria where you would say, yes, we've achieved this market penetration and we know we've got something that's going to be a good sustainable revenue model for us, but we've also helped the world considerably here. And I know in Canada, obviously there's a pretty significant focus there with your First Nations communities, but with a lot of other things as well. Does anything come to mind?
If there was one factor, I would say, Louis, the ground segment is extremely important. Satellites, satellites are complex machines, and building and launching them itself is a complex process. But it all comes down to the ground, and it all comes down to especially what are you giving your customer to connect to the great network that you've built. So if you don't be very radically honest with yourself about how much can the customer afford, and how easy is it for him to install it and operate it, no one's going to come onto the network. So I think we, all of us in the satellite industry, have to be just make sure that we make it as simple and as affordable for the customer to not just get onto our LEO network for sure, but any network that all of us are putting together.
Yeah, and as we say, it'll be the network that again determines whether there's progress or not in so many different areas. And obviously, Telesat LEO plays a significant role there. Manik, I really want to thank you for coming on today. I know you guys are really busy because you're getting a lot of business, but we appreciate you making the time for us.
Thank you for having us, and thank you for the great questions.
You bet. I'd like to thank Manik Vinnakota from Telesat for coming on and talking about Telesat LEO. This series is underwritten by Isotropic Systems. Isotropic Systems is proud to be the sponsor of this series and of its role to make a better satellite world. These podcasts are also brought to you by our corporate partners and the 3,000 members of Space and Satellite Professionals International and our chapters worldwide. You can learn more about the Better Satellite World podcast at bettersatelliteworld.com. And follow us on Twitter at SSPI and check us out on LinkedIn and Facebook. If you'd like to learn more about membership in SSPI and join today, again, go to sspi.org. If you're a student, your membership is free. For Space and Satellite Professionals International and our producer, Ana Gomez, I'm Lou Zaccarella. Let's make it a better satellite world. Thank you, everybody. See you next time.